Hello, in this video I'm going to review the concept of the derivative. A derivative is nothing more than a slope function. So when you think derivative, think slope function. So for example, a derivative will just measure the slope of the original function at a given point. Maybe our original function, just in general notation, looks something like this. Y is a function of x. So the derivative will measure the slope of that function at any value of x. Ways to denote that you're taking a derivative, some common ways of doing that. It can be written like that. Also, f prime of x is a common way of notating a derivative, and also y prime. So what I'm going to do now is go through some rules of differentiation. I'm going to label or name these rules. And the first one here is the constant function rule. Here y is just equal to some constant. If we're going to take the derivative of this, we are going to always get back 0. So for example, if y equals 2.5, the derivative is 0. Y equals 4, the derivative is 0. So the derivative of a function is always, of a constant function here, is always 0. Alright, let's move on to the next rule. Oops. Alright, there we go. Let's now look at the linear function rule. We're going to write an equation, general equation for a line, y equals mx plus b. If you might recall from calculus, m is the slope, b is the vertical intercept, and as we're going to see when we take a derivative being nothing more than a slope function, we get back the slope, okay, m. B is a constant, and as we know from the last rule, the derivative of a constant is 0, so b doesn't hang around here in the result. Here's a linear equation. I'm going to take the derivative of this. According to the rule, we're just going to get back here the m, which is 4 in this case. This rule works fine for downward sloping equations. The derivative here is going to equal minus 1.5, the slope of this downward sloping line. Okay, let's move on to another result. Let's go to the power function rule. Here y equals, in its general form, k times x raised to the power of n. This is the derivative of a power function. Basically, there are two steps involved. First, we bring down the n in front, okay, and then we're going to subtract 1 from n. An example. So you're going to take the derivative of that equation, bring down the 2. 2 is multiplied by 1/2. My equal sign there, sorry. And this will just equal x. Okay, the 2's cancel, and 2 minus 1 just leaves x to the power of 1, or just x. Another example. Get something like that, just 6x. Do some more examples here. Bring down the 3 in front. 3 is going to be multiplied by 4, so you get 12. And you'll be left with 2. Do another example, see if I can squeeze one in over here. Here we can use some of the rules that we've used in the past that I just introduced. So the derivative of a constant is 10. Here we got the derivative of 4x is just going to be 4. And then the power function rule on the last part, we're going to get 4x. So that is the example of the power function rule. Moving on. Oops, didn't want to do that. There we go. Moving on. Let's take a look at the product rule. So y here equals some function g of x multiplied by some function h of x. The derivative will look something like this. First we're going to take the derivative of the g of x function and multiply it by the h of x function. And then we are going to add to it the g of x function multiplied by the derivative of the h of x function. And that is the basic way of taking the derivative of a product. So let's do an example. Say okay, so we've got the g of x part here and the h of x part. Taking the derivative of what's in parentheses first, you're going to get 4x. That's going to be multiplied through by 2x plus 3. So all I did was the first part of this rule. And we're going to add to it g of x. Oops, sorry. Multiplied by the derivative of h of x, the derivative of what's in parentheses here. 2x plus 3 is just 2. And we could simplify that, but that is the basics of taking the product rule. Let's move on to a new one. Let's briefly look here at the quotient rule. With the quotient rule, we're going to have something in this form where y is a function of g of x and h of x, except g of x is divided by h of x. The first thing we want to do here is just square what's in parentheses, and then in the numerator we're going to have that first. You're going to take the derivative of g of x, multiply it through by the h of x function, and then we're going to subtract g of x multiplied by the derivative of the h of x function. Let's do an example. Say okay, so we don't want to take the derivative of that result. Going to square what's in the denominator. That was just now x squared. G of x, the derivative of 2 plus 3x squared, is just 6x. And that's multiplied by h of x. where h of x is just x. Then we're going to subtract out 2 plus 3x squared times the derivative of x, which is just 1. And we could simplify that a little bit too if we'd liked, but in the interest of time I won't do that, and that is the quotient rule. Let me do another rule here called the generalized power function rule. And with the generalized power function rule, I'm going to write it in the basic format like this. So some function here, g of x, is raised to the power n. The derivative of this will look like the following. We need to subtract 1, like the regular power function rule, from the exponent up here. So for example, take the derivative of this, we get the following result. I brought down the 2 in front. From the 2 I subtracted 1, and then I multiplied by the derivative of x squared plus 3, which is just 2x. Okay. Let me take a break now.